Welcome. In this video I will solve question number 1.119 from Problems in General Physics by Irodov. First let's look at the problem. The problem says that a locomotive of mass m starts moving so that its velocity varies according to the law v equals a times root over s, where a is a constant and s is the distance covered. Find the total work performed by all the forces which are acting on the locomotive during the first t seconds after the beginning of motion. Note here that v is expressed as the function of the distance covered. So in order to find the force acting on the particle, we will have to express velocity as a function of time. So let's see how to do it. So this is the expression of velocity, and let's assume that the locomotive is moving along the x-axis, and this is the one-dimensional problem. And again you can see that with the increase in s, velocity is increasing, so we can replace s with x. In the cases where it is a two-dimensional problem, or in cases where velocity reaches a maximum value or then it turns around, it becomes negative, so in those cases we cannot replace s with x. But in this case, as velocity is increasing, for increasing x, increase in s, so we can replace s with x. So velocity is dx by dt, so it times x. So integrating on both sides, we will get, so now we can write x as a function of time by, from that we will get velocity as a function of t as 2a square t. We will get acceleration as a function of t as a square by 2, and the force will be ma, that is the force is equal to ma square by 2. The work performed is, from the definition of work, as it is a one-dimensional case, it reduces to this expression. So we know f is ma square by 2, and we can, so we need the work performed in the first t seconds, so we need it as a function of time. So let's replace dx with, we know that dx by dt is v, so dx equals v into dt. So we can write v is nothing but a square t by 2 times dt. So we need, so for velocity, as velocity is given as a function of distance covered, for distance covered, that is s equals 0, in the initial position velocity is 0. So, and we need to find the work performed by the all the forces work acting on the locomotive when the time is t, the final time is t. So we need to integrate from time is equal to 0, as time equals 0, from initially the velocity was 0. For velocity to be 0, time is 0 from this equation, so we need to integrate from 0 to time t. As given in the equation, we have to integrate it, for we need the work performed for the first t seconds. So after integrating it, we will get a to the power 4 t square divided by 8. This is the expression for work done by all the forces acting on the locomotive of mass m. Thank you for watching, and subscribe to my channel for more solutions to problems in general physics. Thank you.